I will travel where no man has dared to go.
Now we're going to take a look at what happens during a head-on collision and when the two objects that collide do not stick together. How to handle those type of problems. So let's first look at how to handle it when two objects are traveling directly head-on. So here, just like before, we have the same exact variables except we've changed something. Okay, now we say that a 1,250 kilogram green car is moving down the highway with a velocity of 32 meters per second. When it collides head-on with a blue car, which has a mass of 875 kilograms and a velocity of negative 25 meters per second. The main key with all of this, in some problems it'll say west and east, some it'll be negative, positive. You need to keep track of the directions, okay, and which way it's heading, because it's going to say whether the momentums, whether they add to each other or whether they subtract to each other. In this case, the momentums are going to be opposing each other. So even though all momentum is conserved, we're still going to have velocities that wish to cancel each other out. Alright, so starting this problem, we see here that we have our M1 is right here for the green car. And then here's its velocity, 50 meters per second. And the P1, so its momentum total for this, just like in the other problem, it was going to be 40,000. 40,000 kilograms times, that is meter per second. Alright, and now for the blue car. What's different from our last problem is, in our last problem, same thing, same mass, but now we have a negative. So now when I figure out its momentum is going to be in opposition. I'm going to get a negative 21,875. So when I go ahead and I put those together now, I'm going to say P1 plus P2 is equal to, and this I'm going to say momentum total. Okay, and then we know, as always, that P1 prime is going to be after the collision. So if you think about it, this is really what we have before. Okay, so before the collision is in this area. This is at the moment of collision, so the total. And then this is going to be after the collision. Okay, so when I combine 40,000, when I add this 40,000 to a negative 21.875, what I'm going to get is a P total and that is going to equal, this time, 18,125 kilograms times meters per second. So this value, I simply just added these two together, and that's what it gave me. Okay, and now I can look too. This value is negative, this value is positive, and this number is positive. That means that the velocity of both vehicles more than likely will be carrying in this direction. Okay, in this direction for the 1825. So now I know once again that these vehicles are going to be coming at each other. And then they're going to roll back. Okay, so I see that after the collision, the green car rolls ahead at 5 meters per second. What will be the velocity of the blue car after the collision? So let me go ahead and start this part, second part all over. So now I take it from this point. I know that my P total, right, also has to be equal to my prime, my momentum 1 prime plus the momentum of my second object in the prime. And this just means, once again, after the collision. This is during it. And we also know that we have a value, okay, of 18,125 kilograms. Vision there. Kilograms times meters per second. And I know that's going to be equal to the value of this plus the value of this. So how do I find these out? Well, I'm told here that the green car, okay, now has a V1 prime equaling 5 meters per second. And its mass is still the same. Okay, so now how do we deal with this? Its mass is still the same. So now I simply just write down the mass of 1250, and if I go ahead and I multiply them together, I will now get a new value, and that value will be, it'll say that my P1 from this vehicle, taking the 5 times 1250, is equal to 6,250. Okay, so that makes it my P1. So now all I do is have to make this statement correct. So it's 18,125 is equal to 6,250 plus what? So that's my first step, is I have to find my P2 prime. So I just simply take this number and subtract this number. If you do that, 18,125 minus the 6,250, because remember, these two values add up to be this one, and I have this and this. So that means I just have to simply subtract this value from this number, and I'll get P2. Another way to think of it is, this is my total, so what two things make up my total? Right, how much do I have left to spend afterwards? And I know I spent 6,250, so whatever's left over from this 18,125 is what I could spend. So when I do the math on that, I get a P2 prime of 1,875. And that's, once again, in kilograms times meters per second. So then the final thing I have to do is, I have a momentum here. I know that it still has a mass of 875, so I'm just going to take and solve for the simple equation of P is equal to M times V. So I'm just going to take P divided by M, gives me my V. And when I do that, I wind up with a V2 prime equaling 13.57 meters per second. And that is how you solve for this problem. So what it's saying is, these two cars collide. This one slightly rolls. This one goes back much quicker. Okay, so I hope this helps. Thank you.